Hello, my name is Mark Gibson, and you're listening to the podcast version of the Teagasc Signpost Series, a weekly webinar that promotes and examines sustainability in Irish farming.
Good morning and welcome to this week's Signpost Series webinar. You're all very welcome, and this webinar series is brought to you in association with Dairy Sustainability Ireland, National Rural Network and Food Drink Ireland SkillNet. My name is Tom O'Dwyer and I am your host for this morning's webinar. This morning I'm being joined by Barry Caslin. Barry is an Energy and Rural Development Specialist with Teagasc, and Barry will be helping with questions later on the webinar. Good morning, Barry.
Morning, Tom. Good to be here.
Good. And we're delighted to be joined this morning by another Teagasc colleague, JJ Lenihan. JJ is the Buildings Officer with Teagasc, based at our Beef Research Centre, Grange, County Meath. JJ, you're very welcome as well to this morning's webinar. One of the targets for agriculture in the Climate Action Plan of 2023 is to produce up to 1 terawatt hour of energy through biomethane by 2025, and up to 5.7 terawatt hours of energy by 2030. And the Climate Action Plan also indicates a target of the construction of 20 anaerobic digestion facilities by 2025 and up to 200 anaerobic digestion plants by 2030. And the title of our webinar this morning is Biomethane, an Opportunity for Ireland. And I suppose, JJ, my initial question to you before your presentation is, how big of an ambition are the targets in relation to biomethane production from agriculture, and you know, what is the scale of the opportunity that is there for Irish agriculture?
The potential is there to produce the targets, but they are initially to get the industry up and running. Policy will have to be put in place, and you know, take the example of Denmark, where they have a well-developed industry, but it's over a 30-year period. So I think while the targets are good and are challenging, they can be achieved if correct policies are put in place.
So JJ, over to you.
I'm going to start talking about just energy in general in Ireland and where gas sits and where renewable targets are. And if just a bit of its history now, but we had a renewable target for 2020 of 16%. Europe had a 20% target, Ireland had 16%, and that was split into the different categories of energy there as outlined: 40% electricity, 12% heat, 10% transport. And in terms of the results, we failed on all the targets. We got 12 out of the 16, and electricity was 36.5 out of 40. Heat was well below the target, and transport was about just over 1%. But the transport was basically catered for by the government telling oil companies to put X amount of biodiesel into their diesels and X amount of bioethanol into their petrols. Gas, this is SEAI figures, and it shows oil is the big beast in terms of our energy, but natural gas, which is methane, is the second biggest component of our industry. And where we stand in where gas stands in European terms, natural gas is about 25% of European energy demand. In Ireland, again, SEAI figures show the natural gas usage or the natural gas share of our energy going from 22.1 up to 31.3 in 2019, and it is still around that level. So we are above the European average in terms of our use of methane, natural gas. And, you know, there's a lot of talk, or you hear talk about hydrogen as the renewable, as a renewable gas. You know, biomethane is a renewable gas which can replace the gas that's currently used, and where that there is already the infrastructure in place. So, you know, in terms of how quick you can go to market, biomethane would definitely be the gas of choice. And just in terms, there's a lot of move towards electrifying our energy use, and okay, there will be demand for electricity for electric cars, but electricity is 20% of our total energy, heat's 40%, and transport is 40%. Renewable electricity, yes, wind and solar are very important, but when you don't have the wind blowing, you don't have electricity, and when the sun is not, or when the solar panels only react, you don't have a solar panel producing electricity at nighttime. And you can see there, EirGrid dashboard has a continuous daily detail of where our energy, where electricity is coming from. And you can see that situation there where when the wind is not blowing, it's contributing very little to the electricity demand. And the backup is gas. And you can see there a typical breakdown of fuels used for electricity. Gas averages about 40%. We even have coal still in the system, so anybody buying an electric car needs to keep that in mind, that some of that electricity may well be coming from coal. AD, just talking a bit about AD, it's basically a process where you have a sealed vessel, anaerobic conditions, and microorganisms break down biodegradable material to produce biogas, which is predominantly methane and carbon dioxide. And what you do with the biogas, with a combined heat and power plant, you produce electricity and heat, but if you clean it up and remove the carbon dioxide, you produce biomethane, and that can be used for fuel or go into the gas grid and be used by any gas customer. And that's the way the industry is developing in the UK and in Europe. In terms of feedstocks, slurry and manures can be used, food waste can be used, but the interesting one is crops, and where the big resource potentially is from crop-based feedstocks. And in Ireland, the crop of choice would be grass. The other output from your digester is digestate, and that is a potent fertilizer. The European Biogas Association has just produced a report on looking at the whole system's benefits of biomethane. With solar panels or wind turbines, you will have renewable energy, but there are co-benefits with biomethane in terms of you can produce CO2, which is a product in demand industrially. You can process organic wastes, and you have a fertilizer source. So there are additional benefits to having your renewable energy from biomethane. SEAI did a study in 2017. They were updating their renewable energy renewable energy opportunities in Ireland, and they hadn't included grass at that stage. Teagasc, Pádraic O'Reilly had a good bit of work done on looking at other opportunities for grass, and energy from biogas, biomethane was one opportunity. UCC, Jerry Murphy was working also on the area, and indeed Hillsborough had already installed a biogas plant at that stage. We encouraged them to look at grass, and they undertook that study, and basically the output of that was that 25% of our natural gas could come from biomethane. And if you look at the chart there, you will see that waste-based AD will get us about, just around 5%. But to really get the quantity of gas, you need to put in forage-based feedstocks. And the reason being, we're a small country. We only have 4 million people. We only produce so much sewage sludges and food waste. So the big opportunity there was seen as forage crops. And if we look at some research from Germany, we see that if we're looking at using land for energy crops, you can see that grass silage for biomethane, the output per hectare is substantially higher than biodiesel from oilseed rape or bioethanol from wheat. And again, grassland is our big resource in Ireland in terms of agricultural land use. 81% grassland, 11% rough grazing, and only 8% arable, which would be not typical in Europe. And producing grass. Our Grass 10 program in Teagasc shows that, we can produce and utilize 10 tons of dry matter per hectare. And the average production is way, way below that. And, there's a typical field very close to Grange where we would be producing 10, 12 tons of dry matter per hectare. And because of the land management, there's a crop of hay taken off that land in July, and the bales are still there in September. There's no incentive, obviously, to grow more grass because the operator is content with having a low stocking rate, and the financial incentive perhaps is not there to increase it. But there's a lot of land like that around the country. So 5 tons a hectare dry matter output versus 12. And every year that balance or that 7 tons of dry matter is lost, it's lost forever. Talk a bit about the Grange plant, fairly conventional type of plant, concrete tanks, 1,500 cubic meter digestion vessel. We will pre-mix the liquid and solid feedstocks, the forages and the slurry, and that's important with materials like grass because it's difficult to mix within the tank. Whereas you will find if you're using maize, like is predominantly used in Germany, the potential is there to put the liquid into the tank, the solid material into the tank and mix it in there. We also have mechanical mixing in the digestion vessel. Originally, we were looking at CHP to generate electricity. There was a scheme there, Refit 3, wasn't very attractive, wasn't as attractive as the scheme in the north of Ireland, where they built 85 plants or thereabouts based on their renewable obligation certificate scheme. At the initial stage, it was 150 kilowatt electricity output, which is small in European biogas terms. The typical model would have been in Germany 500 kilowatts, and indeed the plants have even got bigger as the market or the industry has moved towards biomethane. We were to use the heat in our bioscience building at Grange, but the opportunity has come to go the biomethane route, and that's the route we are taking. That's the plant under construction. 2 tanks, one is the digester and one is the digestate tank, because every day you will put in some more material into the digester and you will take out some material as digestate. The digester is insulated and clad with steel sheeting, and gas is collected overhead. That's the pre-mixing system where the forages are mixed with slurry before they are put into the digester, and that's the control. The pump station and control center for the development. Just in terms of feedstocks, and these are typical feedstocks which we would be looking at to generate the gas. 9.3 tons a day of silage and 14.5 tons a day of slurry. And if we look at where the gas would come from, although you have a smaller proportion of silage, it produces a bigger proportion of the gas, and it's fairly obvious. The slurry already, the material already has been digested by the animal, and so some of the potential energy is already removed. Just in terms of the scale of feedstock supply needed, that would be the silage from 70 hectares and the winter slurry from 1,000 cattle. So although our biogas plant would be considered small in European terms, in Irish farm size, it would be very large. In terms of feedstock supply, we looked at just an expression of interest in the local paper. We looked for 60 hectares in total with a minimum parcel size of 10 hectares. 15 farms replied, but what was interesting was we were oversubscribed by a factor of 12, which would kind of indicate that study from SEAI would indicate that there is forages, that there is potential out there to produce to produce feedstocks for other uses than feeding to animals. And just if we look at taking a typical plant within a 10-kilometre radius, that harvest hinterland of 10 kilometres has a total area of 31,400, and the average agricultural area in Ireland is 66% of total. Grassland area is 92% of ag area. So if we run down through the figures, we have 19,066 hectares of grass area. If we just capture 10% of that, and then just go after the 5 tonnes per hectare of the additional grass that can be grown, would provide a resource for 10 grange plants. No reduction in milk or meat output. So there is a huge scale of potential out there. Has to be mobilised, has to be done sustainably, has to be done economically, but the potential is there. And indeed, Joe McIntyre undertook research here at Grange back when we were just starting the journey. And if we went after all the land, all the potential that was out there in underutilised land in Ireland, we could produce 44 terawatt hours of biogas or biomethane energy. And that's equivalent to 4 times the SEI estimate. And it's interesting that the current target is 5.7 terawatt hour target. So, you know, it's challenging, but it's potentially achievable. Just some research. Kira Bosang has started recently with us as a researcher on AD, and Kira was working as a postdoc here and doing some work on the sustainability of biomethane, and looking at different feedstocks. And just what's interesting here, you know, conventional perennial ryegrass with 120 kilos per hectare of nitrogen. The other ones, red clover and perennial ryegrass, are multi-species swards without nitrogen, can grow, you know, equivalent amounts of feedstock, which in terms of sustainability is very important. You have to conform to the Renewable Energy Directive. Producing the feedstocks has to be done in a way that is clearly sustainable, and the directive provides, you know, rules on the greenhouse gas emissions. And Kira has been looking at what that means for producing forage feedstocks. The minimum emissions savings required to be deemed renewable on the heat side, 80%, and transport, 65%. You do get credit for manure as a feedstock, so that's important to have in the mix. Basically, on the transport side, all production systems can conform, and on the heat side, we're challenged if we're using grass and nitrogen. If you don't need nitrogen, you won't be using it, because obviously nitrogen costs money. So there's very interesting work going on red clover, following on from work that Pádraig O'Kiley and Dan Clavin did here on small scale plots. That's now being widened out to large scale animal production plots, and are producing forages for AD feedstock. We have work being undertaken by PhD student Sophia Tisocco, and again modelling the process of co-digestion of grass silage and animal slurry, trying to optimise the process. There's a fleet project, transport logistics modelling project being undertaken by Maurice Deasy and Fiona Thorne, and that's looking at accessing feedstocks in different areas of the country, just to show or to demonstrate where the best potential is. And our colleagues in Johnstone Castle are working on specific areas of AD optimization using slurry additives, optimizing AD by using different forage species, and looking at the effects of digestate spreading on land in terms of fertilizer recovery. And just to acknowledge the support we have from the different agencies to carry out this work. Tom mentioned national biomethane targets. Just to put that into perspective, the current natural gas use in Ireland is 54 terawatt hours, and that's about 50% of that is used for electricity generation. The Irish target recently announced is 5.7 terawatt hours by 2030. And that's equivalent to 1,700 grain-sized plants. But as Tom mentioned, they're talking about 200, 250 plants. So, it's larger scale plants. And the opportunity, I think, for farmers will be to become feedstock suppliers. Okay, there will be farmers who will invest in the technology. But in the main, I think the opportunity will develop as feedstock suppliers. In terms of land area, that's 120,000 hectares. It's 3% of agricultural land. So if you look at it like that, it's not a huge amount of land. Some or all of that can be produced in those hidden hectares I talked about by having policy to try to mobilize more grass or forage on land that's currently producing at less than its potential. It's the winter slurry for 1.3 million cattle. And that could be a bigger challenge in the short term than the forage supply. And in terms of what 5.7 terawatt hour target means, it's about 10% of current gas use. And indeed, Europe has a target which is about 10% of European gas use. So we're in line with that target. Just in land use, these are some charts that colleague Kevin Hanrahan produced, not specifically by any means for talking about biomethane, but just it gives a general historical picture of what we did with land. And this is for the main tillage crops going back to 1850. In 1850, we had 600,000 hectares of oats. And if you recall, it's 120,000 hectares of land we needed for the 10% target. And you can see the amount of the land for oats dropping over the years. But why did we have oats? We had 600,000 horses in 1850. They were the engines, they were the energy source of the time. And as you can see, a drop off in oat areas. We got better at growing oats. We had the same number of horses right up till after the Second World War, and then the conventional engines took over all transport and mechanical operations. So the amount of horses dropped. We only grow 25,000 hectares of oats now versus 600,000. So just an interesting bit of data. We had a grass drying industry in Ireland, a very substantial grass drying industry in Ireland to produce protein concentrate feeds for pigs and poultry, and also cattle. That relied on oil to dry the grass. That industry basically went into decline as soybean became the protein concentrate of choice, and the last dryer of grass, I think, is finished 20 years ago. But you can see very substantial areas of grass were being assembled at an industrial scale, and that the figures are there for 1972. And what's interesting, they're fairly well spread across the country. There was a couple in Meath, Offaly, Waterford, Galway, Mayo. So that industry was right across the country, and technology was way at a lower scale than what we have now. So I think assembling the logistics of harvesting and assembling grasses, with that kind of 10-kilometer, 20-kilometer radius is logistically, mechanically, the equipment is there to do it. To talk a bit about Europe, the total natural gas use in Europe is 4,200 terawatt hours, and there's a target of 35 billion cubic meters of that to be biomethane by 2030. 35, it equates to about 10%. Denmark, very interesting country. Comparable to ourselves, use a bit less gas than we do. They are currently at 25% renewable gas. and they aim to have 75% by 2025 and 100% by 2030. That process didn't happen overnight. This is just an excerpt from an environmental impact conference in Teagasc in 1991. And that's, it's over 30 years ago. But there was a small scale AD plant in Caslin, a research plant been monitored by OLIS. They had problems with surplus pig slurry in the area. And Tygo Flaherty's summary from that report was that the best solution to handle the slurry surplus in the Caslin area was to establish a full-scale central treatment plant along the lines of the plant at Lintop in Denmark. And, look where Denmark are now. So Ireland are only at the start of the journey, but if we can follow the model that Denmark have done, those targets are achievable. And I just go back to the hidden hectares because there's this fear maybe that we will impact on our ability to produce forages for animals. The hidden hectares are there as a potential resource. Nationally, they could serve as 2,240 plants the size of Grange. Now, as we know, the plants will be bigger, but the scale is there to get forages from those hidden hectares. And 10% of hidden hectares will provide 5% of total energy. 20% likewise will be 10% of energy. 30% would provide 15% of energy demand. So there is a large resource out there. Of course, the other potential opportunity is if we do have to reduce animal numbers because of greenhouse gas emissions, production of forages is a production of forages for AD is a relatively easy, practical solution for farmers to use their land. They know how to grow the crops. They know how to harvest them. It's not a whole new education job that's needed, or indeed a commitment to crops. We say forestry. Commitment to forestry has been, we'll say, not the numbers haven't been as successful as we probably thought they would be. Whereas it would be a much easier adoption of or reuse of land to use it for forage crops for AD. That's the Grange plant, just ready. We're almost ready to go. We got some delay in the supply of our upgrader, most of the technology on site. So by the middle of the year, we will be producing biogas, cleaning up the biogas to biomethane, and also utilizing the CO2.
Thanks very much, JJ. Very interesting presentation. And I was quite interested to see the small history lesson built into your presentation, and for me, I suppose it points out that our farming systems change over time. So this could be a change that maybe in 20 or 30 or 40 years' time, we look back and say, oh yeah, we used to do that, but now we're doing a lot of it. So quite interesting. But on that, I'll just ask one question, kind of related to that. And it came in on the chat there from Catherine in relation to the hidden hectares, and you did clarify it a little bit towards the end of your presentation. But I suppose one of the things that struck me, if you have your anaerobic digestion plant in an area surrounded by hidden hectares, let's just say, it would strike me that you won't have the slurry, okay, that the animals won't be there. Whereas if you try to locate the plant in an area where there are a lot of animals currently, there won't be as many hidden hectares. So do you see the
Yes, in terms of logistics, Tom, yeah, obviously the ideal location will be in an area where you have both feedstocks close by. And I think there are low-hanging fruit for the initial targets. There's a lot of very large-scale beef finishing feedlots in the country where there's cattle in all year round. and they tend to be in areas, where there's substantial grass production. It's easier to move logistically to move the grass the distance because there's more energy in it. In terms of slurry movement, there would be research going on and in pre-processing the slurry, dewatering it before you would transport it. So I think they're all things that can happen as the industry develops. The mushroom industry developed in Monaghan, and there was large-scale movement of straw, there was not much tillage in Monaghan, and the straw was all moved up there to produce compost. And I think the logistical problem will be solved once the industry is economic.
Okay, and I'm just going to ask one other question linked to that, because it also came in the chat from Keane in relation to the hidden hectares that you refer to currently farmed at a low level of intensity, as per your description in the presentation, and the potential to produce more grass. Those areas that are farmed less intensively, I suppose, are probably more valuable for biodiversity currently. And if we move to farming them more intensively, there could be an unintended consequence of perhaps a negative impact on biodiversity on some of those areas. Would you care to comment?
Yes, it's important to look after biodiversity, and that will be and is part of research that we would be undertaking. But if you look at we only need 3% of agricultural land to produce all the feedstock in the country. So relative to our total land base, what's needed is relatively small. And I think the industry acknowledges that it has to do this sustainably. So the RGFI have undertaken some studies to show that the land is there, and the percentage of land that you're using is managed in a way that we won't be impacting negatively on biodiversity.
Okay. Barry, I'll hand over to you now. There's a lot of questions in on the chat. People are obviously very interested in the topic. You might pose some of those questions to JJ now.
Yeah, a lot of interest, especially, I suppose this is on the environmental theme as well, Tom, and a lot of queries in the whole area of sustainability and sustainability criteria. And I know they're coming from Mary and George and Kane. Kane's is linked to that as well, that question, but is what kind of sustainability criteria is there to ensure that AD biogas plants won't lead to further environmental issues or challenges? That's the general theme of what's coming in on the sustainability stuff there, JJ.
Yeah, well, I did mention some of the work that Ciara Bosang is undertaking in Grange with the Renewable Energy Directive, and for your gas to comply as a renewable gas, you have to follow those targets. Now, those targets, I think, originally are focused on using wheat for bioethanol and maize for energy, and grass has to conform as well. But the fact that we can, use a crop like red clover to produce our forage and produce 12 tons of dry matter per hectare without any nitrogen, allows a very interesting. When you do the studies, you get very interesting results in terms of sustainability. Red clover is a bit more challenging multi-cut system, but red clover is used by organic farms. Red clover was a very important crop 50 years ago, before nitrogen became before artificial nitrogen was available and was cheap. Red clover was what you used to produce your nitrogen, red and white clover.
JJ, sorry, could I just interrupt? Would you mind stop sharing your screen, and Barry, you can continue then with the questions.
Yeah, I just think on that point as well, on the sustainability criteria, just to point it out as well, that for biomethane gas from AD plants, if they're to be classified as a zero carbon renewable fuel, the plants have to be able to achieve strict sustainability criteria, and that's outlined within what's called the EU Renewable Energy Directive. So it's RED 2. and the future one that's coming is RED 3. So it's important that people are aware of that RED 2 and RED 3, that's Renewable Energy Directive 2 and 3 that's coming fairly soon, that's stipulating strict controls in relation to biomass fuels that are used to produce renewable energy. And some of those things will be in the likes of the land that was formerly peatland. You can't derive the material from that type of land that was formerly peatland. Land that would be high biodiversity value, that cannot be used either. So there will be strict criteria, and also land with high carbon stock that would be eliminated. So, capturing the methane from the slurry, that reduces very significantly the amount that's been released to the atmosphere as well. So that's a very positive for the environment. So it's been carbon negative, and it's improving the overall greenhouse gas savings of the AD facility as well. JJ, there's a question coming in there in relation to the type of supports that are available. Is there any supports there at the moment that's making biomethane happen, or are there planned supports?
We haven't had a good history in terms of supporting biogas yet in the country. The Refit 3 scheme, there's a couple of biogas plants got up and running, but their business model was to have a feedstock with a gate fee, a waste feedstock that came to the plant with a gate fee. And by all means, they're important plants, and they're doing a job managing organic wastes. Other countries have come in to support the industry, and I think that's part of what's happening at the moment. There is work going on to develop the final policy, which will include incentives that will allow us to get the targets. Two types of incentive: a capital, because the equipment and the technology is expensive. So that is one element, to have aid for capital investment, but also aid for the amount of gas produced. If there's aid for the amount of gas produced, there's a continuous incentive to keep your plant running. But I think what is interesting, customers are looking for biomethane across Europe, and you can source gas through the gas grid. We import gas through the grid, but we can also export gas. It won't be the actual molecules of gas, but it would be on a certificate system, whereby if somebody puts renewable gas into the grid in any part of Europe, a customer in a different part of Europe can utilize that. So there's interesting things happening, and I think the policy makers, will finally crystallize, incentives that can allow plants to go ahead. The targets are there. Sorry, Barry.
And I think that the kind of the policy mechanism, because there's a good few queries about that, is what sort of support mechanism will be there. And I hear the renewable heat obligation that should be up and running next year. Do you feel that's going to be a good support mechanism for the industry?
Well, it'll be a start. I mean, if there's something guaranteed, it has to be at a level that makes things economic. If things are not economic if the economic model doesn't work, the practical systems won't be put in place.
Yeah, just to explain that to the listeners there, that the renewable heat obligation is going to require the fuel suppliers in the heat sector to ensure that a percentage of the fuel that they supply, that it comes from renewable sources. So biomethane will likely be used to help meet the obligations for the natural gas customers in the country. So that's what. Sorry, Tom, you were going to say something there.
Yeah, I was just going to come in there because I'm just looking at the questions as well, and talk of incentives. There's a number of questions in relation to the incentive to the farmer to supply the grass or supply the feedstock. I suppose the previous answer was relating to the incentive to the operator of the plant, I guess, to establish the plant. So JJ, one or two questions in there on the questions and answers in relation to when you looked for the supply of grass for the plant in Grange, what type of level of remuneration was offered to the farmers?
we would buy silage directly for use with cattle over the years, and the figure, things have changed in the last year with increased fuel costs and increased harvesting costs. We didn't actually have, that was an expression of interest. We didn't put a figure on it at that stage, but it will be critical. I mean, farmers won't produce silage for biogas plants for the farm to run at a loss. So I think there are some interesting things. Harvesting silage is a big cost, but if you're running a biogas plant and using silage, you will have, I would say, at least 4 cuts of silage a year. That's not typical of what we ask the contractors to do at the moment. Everybody wants the contractor, 2 weeks in middle of May to the middle, the end of May, first week in June, and then they have nothing to do. Whereas if the work is more balanced, the cost can reduce. Now, look at silage harvesting costs have gone up, and that's a reflection on fuel costs. But I think fuel costs, will trend downwards if the problems in the Ukraine are sorted out, and that type of, a guaranteed level of work over a longer period will also should also impact on the level of cost. Look at the plants will have the feedstock producers will have to get remunerated, because if they don't produce feedstock, the plants can't operate. So I think there's a balance there.
Will there be a payment to the farmers for the supply of slurry also, or are they just, I'll use the term, loaning the slurry to the anaerobic digester, and it comes back as a valuable product, the digestate?
I think in the short term, probably the real advantage of a biomethane plant in an area would be to deal with surplus slurries. Farmers who are operating, we'll say, a nitrate irrigation, if a biogas plant could manage that material, would mean that farmer had to have less storage on the farm, would mean that the nutrients were sent to a deficit area after the biomethane, after the digestion process. It could be very interesting that it might be actually a service that people would be willing to pay for.
Right. Okay. I hadn't thought of that.
There's a good few queries coming in here about the feedstocks that would be required by a typical biomethane plant. So obviously the Grange plant wouldn't be your typical biomethane plant. But do you want to go through maybe some of the figures, what will be needed, and how much land will be required in the country to meet that?
Yeah, well, like the Grange plant would be the silage from the typical silage production from 70 hectares, and the slurry from upwards to 1,000 cattle, and it's just multiplied up. If you build a plant 10 times that size, it's 700 hectares and 10,000 cattle. So I did say that the slurry will be the bigger challenge, and like the slurry is important because of the sustainability, but increasing the use of clover helps you get there. And we're not starting an industry in Ireland that's not well developed in a lot of other countries in Europe, and we're probably in a nice position where we can cherry pick the good parts and ensure that whatever we do is done in the best possible manner.
I see that the last GNI report, it looked as a 20 gigawatt hour biomethane plant that would require in the region around 37,000 ton of feedstock. That'll be about 60% of that will be crops, and 40% of that will be animal slurry. So yes, you can't put in fully 100% grass for the sustainability criteria as per the RED 2 directive. So it's going to be around 400 to 500 hectares of land will be required for your typical 20 gigawatt hour plant. I think some of these plants maybe double that. You might see 40 gigawatt hour plants, and again that'll have a larger requirement. But a 20 gigawatt hour plant, based on that report, it required around 4% of the feedstock from the land within a 10-kilometer radius around it. So I think there'll be somewhere between 200 and 260 biogas plants that will have that 20 gigawatt hour capacity. And I think the figure, JJ, was 120,000 hectares that will be needed for grass silage to meet this 5.7 terawatt hour target by 2030. There's a query in there: am I allowed to take slurry from a neighbouring farm, or is a waste license needed?
Okay, with there's a licensing scheme that you have to conform to Department of Agriculture, and once you get into multiple farms supplying, you have to pasteurize the material. We don't have to pasteurize because we are just producing the slurry ourselves. The larger plants will pasteurize and be able to take slurry from multiple sources.
Yeah, I think it's important to say as well about the animal byproducts regulations, that they're classifying livestock waste such as cattle slurry and manure, that they're class 2 animal byproducts. So the use of feedstocks such as that in a biogas plant is subject to lots of different constraints, like thermal treatment, size reduction, and there's a lot of capital investment that's needed. So there's a lot of, and the Department of Agriculture are involved in that process as well. And I think that the only exception there is for you're taking in small volumes of slurry from a single farmer, and it has to be less than 5,000 tons of fresh material per year that's processed on farm in the biogas plant. Then it doesn't have to conform to the animal byproducts conditions. But a lot of questions there as well about digestate. Will it be safe to put digestate back onto agricultural land from the proposed biomethane plants, and how much digestate will be generated?
I think that's a very interesting area, and particularly with the increasing costs in fertilizer and the sustainability required in production of fertilizer, digestate can be turned into a fertilizer product that should be on par with conventional fertilizers. And I think that's the way. Look, there are developments in Europe happening, in that space, and it's an area that we will be looking at also. That you have NP and K available. The biogas process does not remove any of those nutrients, so they're all potentially available. The simplest way will be to spread them as a liquid material, as through a trailing shoe or dribble bar, but you also have the potential to process and segregate out nutrients out of that material. So I think that'll be a very interesting space over the next 5 or 10 years. I think the use of clover is very interesting as well. And this, look at clover, has been a crop that probably lost its people lost interest in it as nitrogen was the reliable and cheap way to grow grass. But as I said, the organic people always had clover, and it's becoming much more important again. The work from Dan Clavin and Pádraig Ó Cailí, shows that you can grow crops of, your 12 tons of dry matter per hectare with no nitrogen. So in a feedstock for a biogas plant, you actually potentially, are operating that you don't need any of the nitrogen to go back out onto your feedstock land, and the nitrogen that's in there from the animal slurries can basically be segregated and used, in deficit areas. So I think, it all takes money and technology. In the past, fertilizer was cheap and there wasn't as such concern for environmental sustainability. So these things weren't managed in a way that optimized the utilization. But I think, we're in a space now where you will find that those type of technologies will have a place.
Yeah, I think that's an important point JG made there about the management as well. And I think that the management of the digestate is going to be so important. It's going to be a key aspect of any new AD plant that's going to be developed. That'll be establishing a nutrient management plan together with the farmers in the vicinity, because, it will require a lot of spread land, but it will be a valuable nutrient for those farmers, as you mentioned, in the absence, in an era of high fertilizer prices. You're taking this material, which is a nitrogen value of maybe 3.6 kilograms per fresh ton. Maybe there's a phosphorus content, there's a potassium content in it as well. So it does have a very high value, and of course it's in the ammonia form as well, which is more available to the growing plant. But there will be a requirement, of course, to use your trailing shoe or direct injection. You wouldn't be able to use splash plates, or otherwise you're creating other environmental issues associated with it.
Question that comes to mind for me, JJ, is the return of the digestate to the farmer. Will the farmer require a separate storage tank for that on its return to the farm, because it may not be possible to land spread that at all times of the year?
Yeah, look, at what's interesting is that whole pathway and movement of material. In our case here, we actually operate under nitrate irrigation on the farm here in Grange, because of the type of stocking rates we have. And we deal with a number of local farmers over the years. Now that we're looking at the digestate availability, and which will be a higher grade fertilizer source, we have people talking about perhaps maybe a tillage farmer constructing a store on their farm to allow material to be transferred to be readily available for spreading. I'm not too worried about those problems. I think if you look at what's happened in other countries in Europe, that in Denmark, centralized storage was one of the key drivers, or it allowed the economics to be attractive, that the AD plant was providing the storage, so the farmers didn't have to provide so much storage, on the farm. So I think we have to look at this slightly different maybe than the strict rules that are there at the moment. If you were starting off a farm on a greenfield site now that was going to send their slurry to a digestate plant, you probably don't need you practically don't need the storage on the farm. Let the storage be provided at scale. So, I think, things will develop. Look, we have to start, the industry has to start before these become any sort of problems, Tom, I think.
Question there in relation.
Another question is in the chat there, is in relation to, you've mentioned Denmark quite a bit in your presentation and answer to questions, JJ, but a significant anaerobic digestion industry has developed in Northern Ireland over a short period of time. Are there lessons to learn from Northern Ireland? And I think the question specifically refers to, are we engaging with colleagues in Northern Ireland to find out, what are the ways to do this, and what are the mistakes to avoid?
We would be in regular contact with the people in Hillsborough who are running a biogas plant up there for a number of years. In terms of lessons we can learn, look, if a biogas plant is built in an area, there's an additional demand on feedstocks, which pushes prices up. And, that may feel, there may be certain negativity coming from looking at that way. But if the biogas plant is producing a solution for a surplus nutrients, slurry nutrient problem, there's a benefit to have the biogas plant in the area. Look, at some feedstocks for the AD plants in North of Ireland are being produced as very close here to Grange. Maize went to the North of Ireland. Yeah, I'd suggest that the industry would need to look at that. That's probably not the best way to provide feedstocks.
Question there, JJ, in relation to poultry manure. Of course, we have a number of broiler producers across the country there. Can broiler litter be used? In areas where it cannot be used.
Yeah, a challenge with high nitrogen. I know there are plants. We have no experience here working with poultry manure on a lab scale even, but there are plants running with poultry manure, but there are additional challenges. You have to get the nitrogen carbon balance right in there, and it may mean that you use other feedstocks to balance out the material.
Yeah. Question there: do you think the weather in Ireland is good to produce biogas?
It's good to produce grass. So grass is the feedstock. We have like the last couple of weeks haven't been great for grass, but then February was a great month. So I think, like in European terms, Ireland can produce the highest dry matter, tons of dry matter per hectare on grassland. So, grassland will, I think, is the crop of choice for AD feedstocks, and probably for clover will be very important, and the multi-species swards with the results that are coming back from there. They offer additional challenges for making silage. The multi-species swards would offer additional challenges for wilting. Clover probably not as challenging, but a little bit maybe more challenging than grass. But I think we can get there. We can get there.
Yeah, lots of queries coming in relation to...
Final question for you, Barry, because we're up against our time.
Yeah, we're tight.
No, go ahead, Barry.
Oh yeah, sorry. Yeah. Well, look, there's loads of questions. We won't get to them. A lot of them around the whole area of the nutrient issues and all the digestate that will be produced, and I think we've covered that in relation to the nutrient management plans. Final question: is there more potential to use barley straw rather than grass silage, as the biogas potential of straw is multiple that of grass?
The biogas, look, it's not something that we've worked on. Biogas potential of straw, pre-processing of straw needed to make it work. And look, we don't have that much straw in the country. We have a much bigger potential with grass. So, like, we'll be open to all opportunities, but definitely in terms of the studies have shown that grass is the feedstock for Ireland.
Okay, and just one final question for me, JJ, in relation to the supply of slurry. Is there a year-round supply of slurry needed as a feedstock?
Yes, the short answer is yes, but we'll say for the Grange plant, we would be aiming to run it on lower slurry during the summer and higher slurry during the winter. Okay. But you need slurry all year round, and that's potentially the low hanging fruit is cattle feed, beef feedlots, piggeries. That's the low hanging fruit right. where the industry should target.
And just to kind of put it in perspective there, Tom, the winter slurry, based on the 5.7 terawatt hour target, the winter slurry from 1.3 million cattle is going to be needed, and that represents about 20% of all cattle slurry produced in Ireland. So it's quite a bit to be gathered up.
Yeah.
I did say that's the bigger, that could be the bigger challenge in the short term.
Yeah, and the logistical challenge of transporting it, but I guess that's all a manageable problem if the economics of the system stacks up. People will make it happen, or solutions will be found, I guess. So that's probably the important piece to get right. Okay, look, as Barry has already said, there was a lot of questions in the chat. We've gone through as many of them as our time has allowed, but others we won't be able to get to, given that we have to try and wrap this up. It's now 10:30. So thank you very much, JJ, and also to Barry to JJ for your presentation and your answers, and also to Barry for asking the questions. Next Friday, there's going to be a short break in the Signpost Series webinars, as it's Good Friday. We will return with our next episode of the Signpost Series webinar on Friday, the 14th of April at 9:30 a.m. And on that morning, we'll joined by Jeremy McCutcheon, a Specialist Pig Development Officer with Teagasc, who will share his knowledge around the Irish pig sector and the environment on that morning. So that's on the next webinar is on Friday, the 14th of April. No Signpost Series webinar next Friday morning. So all that's left for me to do now at this stage is thank you very much all for joining us this morning. Hope you have a great weekend, and wish you a happy Easter. And finally then to thank our production team this morning of Yvonne Marr and Andy Boland. Thank you.
You've been listening to the podcast version of the Teagasc Signpost Series, the weekly webinar that promotes and examines sustainability in Irish farming. Don't forget to join us live every Friday morning for our latest webinar. For more, visit teagasc.ie. And you can also rate, review, and subscribe to the Signpost Series on Apple Podcasts, Spotify, or wherever you get your podcasts from. I'm Mark Gibson, and thanks for listening.